This is the third in a multi-series on the Liebreich ladder titled Biomass Biogas. And it applies mostly to the B and C rungs on the ladder and calls out, in particular, methanol and long-haul aviation. Methanol is a simplest alcohol. It's a chemical building block for hundreds of everyday products, plastics, paints, car parts, and construction materials. It's a clean energy resource used to fuel cars, trucks, buses, ships, fuel cells, boilers, and cook stoves. It stores half the energy of traditional petroleum-based gasoline, but is cleaner. No soot, particles, particulates, or other residue. And combustion of it produces less of the harmful greenhouse gases in the form of nitrogen oxides, NOx. Liebreich talks about a hydrogen-powered JCB, a backhoe type of device, in the category of non-road mobile machinery. It was formerly known as off-road vehicles, and is what you see in this particular version of the Liebreich ladder. Has little advantage over biogas. Hydrogen does. Both hydrogen and biogas currently have underdeveloped distribution networks, so there's no advantage to using either for that purpose. And they're both being used in an internal combustion engine, which produces NOx, as opposed to a fuel cell, which does not. So when we look at non-road mobile machinery or off-road vehicles, we see that biomass, biogas is considered, even by Liebreich himself, as a viable fuel for non-road mobile machinery like loaders, that sort of thing. Now, when it comes to long-haul aviation, we've talked about the storage constraints, both for pressure and for temperature, and why hydrogen's not viable for jet fuel. Because the hydrogen really has to be injected or emitted, exhausted, if you will, with the thrust. So there's not a fuel cell capability here. And Martin claims that fan blades in the jet engine are as efficient as an affordable fuel cell in processing fuel into thrust. The hydrogen, if it were to be injected into a jet engine, would burn at a higher temperature than does ordinary jet fuel, also known as kerosene, which means more NOx are produced. It also, burning hydrogen exhausts water and creates more contrails than kerosene jet fuel, especially in night flights. And as Barnard points out in an interview with Paul Martin, jet exhaust puts moisture in a place where it captures more heat, causing global warming, and the contrails reflect more infrared, which reduces heat loss. Martin points out that biofuels will create carbon, and we will need to fly less to compensate. In other words, we have to begin to return to flying as a luxury, not as a commodity. We should fly less at night because the contrails form more condensation at night than in the daytime. And we should fly at a lower altitude, which avoids contrails and does consume more, but lower carbon biofuels. By the way, Achilles heel alert, Paul Martin eats meat, and livestock produce 14.5% of greenhouse gases.